Okay, today we are going to cover on the chapter on indices, surds and logarithms. So before we start, let us make clear what are our learning objectives for today. Basically, you will get to learn how to simplify expressions and solve equations involving surds, to apply the laws of logarithms and change of base formula to solve the logarithmic equations, and to solve exponential equations, to sketch the graphs of exponential and logarithmic functions, as well as to model and solve problems in the sciences and in the real-world context using exponential and logarithmic equations. Now, if you were to look at this handout that I've just emailed you, okay, the ones with the stars are actually not covered for the normal academic syllabus, but if you're in an express stream, of course all these subunits of the topic will be required for you to learn along the way. So to start off first, okay, we are going to learn on indices. In fact, I believe this is a revision of what you have done for your normal elementary mathematics indices, but of course the questions that they will ask will definitely be much more difficult. Okay, so just a quick one, we have actually studied the 10 laws of indices in our elementary mathematics. Okay, so if you look at law number 1, a to the power of m times a to the power of n is equal to a to the power of m plus n. Okay, law 2, a to the power of m divided by a to the power of n is equal to a to the power of m minus n. So for both laws, law 1 and law 2, we are looking at the same base, which is a, but the powers are different. So the multiplication of the same base with different powers will basically be just adding of their powers, and the division of two indices of the same base but different powers will basically be done just by subtracting the powers. Okay. Okay, if you look at law 3, okay, a to the power of m bracket to the power of n is equal to a to the power of mn, where you multiply both powers together. And then for law number 4 now and law number 5, we are looking at the same index or the same power but different base. So a to the power of n times b to the power of n is equal to ab bracket to the power of n. And for law number 5, a over n over b over n is equal to a over b, everything to the power of n. Okay, so now there are some basic information on your right that you have to know. So if the bases a and b are negative, then the indices m and n, okay, must be integers, okay, for laws number 1 to 5 to apply. So okay, let's move downwards. Now if the base a is more than 0, okay, then indices m and n are positive integers. Okay, then you have all these laws. So law 6 is the easiest law to remember. Anything to the power of 0 is equivalent to 1. Okay, law number 7, a to the power of minus n is equal to 1 over a to the power of n. A negative power on the base can basically be flipped over, okay, by representing in the reciprocal manner 1 over a to the power of n. Now law number 8, a over b to the power of minus n is equal to b over a to the power of n. So basically, if you have a negative power, you just have to swap the fraction by flipping it around and you change the power to positive. Now law number 10, a to the power of 1 over n is equal to a root n. Okay, so if it's a to the power of 1 over 4, okay, then it's a root 4. Now law number 10 is an extension. A to the power of m over n is equal to a to the power of m root n. Okay, so okay, now I think this power table is very important. As I've shared with you before, it is very important that you know and memorize all the different powers. So for example, 8 will be equal to 2 to the power of 3 if you look from this table here. Okay, do you see this? N is equal to 3, meaning 27 is equal to 3 to the power of 3. Okay, so on and so forth. Okay, let's go to the next page. Okay, now you are to solve each of the following equations. Okay, so look at example 1a. 2 to the power of x is equal to 16. Now you must know that 16, based on the power table earlier on, you can then express it in the form of 2 to the power of 4. Okay, with that I will write like that. Okay, 2 to the power of x is equal to 2 to the power of 4. Therefore x is equal to 4. Okay, now this is pretty straightforward, so you shouldn't have much of a problem doing this, I hope. Now let's look at question example 1b. 5 to the power of 2y times 3 to the power of y is equal to 1 over 75. Okay, so if you look at this 5 to the power of 2 is basically 25 to the power of y. Okay, multiply by 3 to the power of y is equal to, okay, I am going to flip this and change it to 75 to the power of minus 1. If you recall the law earlier on, this will be law number 7. Okay, so okay, now if you look at this, they share the same power, correct, but their base is different, so I can then combine them together like that. 25 multiply by 3 to the power of y is equal to 75 to the power of minus 1. Okay, so based on law number 4, you can then combine these together. Okay, then it will get 75 to the power of y is equal to 75 to the power of minus 1. So if you were to compare both sides of the equation, you realize that they share the same base, and therefore y is equal to minus 1. Okay, so okay, let us continue. Okay, I am not going to do all the questions here. I think you'll be good if you can give it a try. Now just to give you some tips for this question here. Now this one, okay, whenever you see 1, okay, please remind yourself of law number 6, where anything to the power of 0 is 1. So to start off this question, you will have 6 to the power of 1 minus k square is equal to 6 to the power of 0. Okay, then from there you will then equate the power to be equal, and then you find what's the value of k. Okay, so okay, I am going to do example 3 instead, because this is the part where it differentiates between E-Maths and A-Maths indices. So let's look at this question. 9 to the power of x plus 1 is equal to 1 minus 8 bracket 3 to the power of x. Now you have to split this 9 to the power of x plus 1 up in this format. 9 to the power of x times 9 to the power of 1. Okay, then I'm going to bring this over, plus 8 3 to the power of x minus 1 equals to 0. Okay, so okay, if you were to look at this, I can actually express it as 3 to the power of 2x, correct? because 9 is 3 to the power of 2, multiplied by 9, okay, plus 8, okay, this one I'll just write down as per norm, okay. Now this is the part where you have to learn. As you look on this table on the right, you have to learn how to do substitution, okay, meaning I am going to let y equate y is equal to 3 to the power of x, okay, then I will have what, 9y square, okay. 3 to the power of 2x is actually 3 to the power of x square, so it's y square. Y square multiplied by 9 is 9y square, plus 8y minus 1 is equal to 0. Okay, do you understand? Okay, so then I will of course factorize, and you should get 9y minus 1 y plus 1 equals 0. Okay, then you will find out that y is 1 over 9, or y is minus 1. Okay, then always remember to sub back into the original equation. So if y is 1 over 9, it means 3 to the power of x is 1 over 9, 3 to the power of x is minus 1. Okay, this has no solution. Okay, and then for this, you flip up, you will get 3 to the power of x is equal to 3 to the power of minus 2. Okay, because 9 is equal to 3 to the power of 2, but you have to flip it up in the reciprocal manner, is 3 to the power of minus 2. So x is minus 2. Okay, so I hope you understand this. Always remember that whenever you have something to the power of something, the answer will not be a negative number. If it is a negative number, there's no solution. It is undefined. Okay, so moving on from here, I believe you can then try example 4. Okay, example 5 as well. Okay, but example 5, when you are solving which part, let me see, when you are solving part B, this part, you will have to use factor theorem. Okay, so I give you a tip here. Okay, you go home and try yourself out. Okay, okay, maybe we will leave the simultaneous equation alone as for now. So I want you to complete the remaining examples, okay, all the way to example 5. Can? Okay, with that, we shall end today's lesson.